This video is going to cover section 4.7, inverse trigonometric functions, still part of unit 4, trigonometry. There is a note here at the top that we're going to be using tab 9 from our foldables. Just really quickly, that's this tab, the one that has your functions. And in particular, we're going to be looking at these two just briefly, because I mean, most of the work is algebraic, but these are the two graphs that we're kind of looking at right now. Okay, arcsine, arccosine, and arctangent. I'm sorry, three graphs, arctangent. They look quite different from our, three original graphs, and there's a reason why. Okay, so let's go ahead and begin. We have that the inverse, we're starting with sine, by the way, just to kind of show where the rest of them come from. The inverse sine function is defined by these two things right here. Y equals arcsine of x, or y equals sine inverse of x. Be careful with this one because a lot of people might think that that -1 just means we're going to write it as 1 over sine, but that's not quite right. This is to be denoted as an inverse function. 1 over sine is a reciprocal function, and this one is the inverse. So please keep that in mind. They're not the same. Um, and if this is true, this is an equivalent statement to sine of y equals x. So if you kind of go back to what you know about inverses, you know that when we're trying to find the inverse of a function, all we basically do is switch x and y, right? So if you had like sine of x is equal to y, that would be our original function. That would be this top one right here, y equals sine of x. If I switch the x and the y, so if I take this y and this x and swap them, I get this right here, okay? And what ends up happening is we have this new weird looking graph, which I already kind of showed you again. Here it is again. It's this one right here, kind of like one little curve and that's it. And it has some interesting restrictions, okay? So the x is now going to be between -1 and 1. So remember that your sine function was between -1 and 1 on the range. So now it's the x. And our y is actually going to be restricted between -pi halves and pi halves. So the reason we have it restricted to this and not to the real numbers is because if we did if you took, and let me just show you that part. If you took this sine function and you kind of tried to flip it diagonally, well, you would end up with something kind of like, maybe like that. And this is not a function. It would fail the vertical line test. It would look not just like this, but it would be some kind of flip where you're going to have some of them repeating. So because of that, we do have to restrict it to just this little piece right here, okay? And what ends up happening is we basically are just looking at quadrant 1 and 4 for this function. I did add that last part because it's going to help us with some of the problems. Um, restricted to make a valid function, exactly what I just said about our vertical line test. So let's go ahead and start some problems. These ones are a little bit tricky at first. Once you get the hang of them, though, they're not too bad. So let's look at letter A first. We have find the exact value of arcsine of -1/2. Okay, so what I'm going to do for this is I'm going to rewrite this in terms of the other one. So here's our solution. We're going to rewrite it with the equivalent statement sine of y equals x. And basically what I'm doing is I'm going to plug in this value into here where my x is because this represents x. And I'm going to ask myself, where is my sine, so where is the y value equal to -1/2? Okay, so where does this happen? Well, it happens in a few places, okay? It happens in quadrant 4. It also happens, let me get my other foldable real quick. We're looking for -1/2. Okay, so let's look at, not this one, maybe this one. Yeah, so we have a bunch of 1/2s on this one. So I'm looking for where y is equal to -1/2. I see it here, -1/2, and I see it here, -1/2. Okay. Now this is where it gets a little tricky because you're only going to have one answer. So we do have to go back to our restrictions and say, well, we're only going to look at quadrant 1 and 4. So up here we had quadrant 1 and 4 because that is where our range is restricted. So I'm going to look at this one, the second one that I kind of chose, which would be quadrant 4. So right here, -1/2, this is quadrant 4. So that's what I did. It says in quadrant 4, at 11 pi over 6 or negative pi over 6 amongst others. So what I mean to say is if I were to kind of go around the circle, it would be 1 pi 6, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, actually that should be a 10, not 11, my bad. It should be a 10. Or actually no, 10, 11. No, I'm right. It was 11. 11. But it doesn't matter because 11 pi over 6 is not within my restrictions up here, okay? 11 pi over 6 is way too big. It's bigger than these two things here. It's outside of that interval. So we're going to have to use the negative equivalent. So if I were to go negative angles, if I go this way clockwise, well, this is now going to be negative pi over 6. So that's the one that I'm going to choose, negative pi over 6. And I did put amongst others because you know that if we keep going around the circle over and over and over, we could get more coterminal angles, but we want one that is within our intervals. Okay, so choose a value that lies in the range of arc sine. So remember, our range is between negative pi halves and pi halves, basically quadrant 1 and 4. So we chose this one, negative pi over 6. So the answer is sine of negative pi over 6 is equal to negative 1/2. Or if you want, you could also rewrite it like this. So this was the original question. There's our answer. And that is it. Okay, let's look at another example. This one is sine, so it has a different notation. This is the one with the little -1, but remember it means the same thing. This means inverse, okay? So remember this means inverse, not 1 over sine. It's not 1 over sine. So make sure that this is not the same thing. This means inverse. So now we're going to do the same thing, and I'm kind of showing you the solution a little bit ahead of time here. We rewrite this with the equivalence statement. So if and only if, that's what this means, if and only if, sine of y is equal to square root of 3 over 2. Okay, so I'm just replacing my x over here on this side. So where does this happen? Well, if you look at your coordinates again, this happens in quadrant 1 and 2 at pi thirds and 2 pi thirds. So I guess I can show you. Where is my y value equal to square root of 3 over 2? It's right here, and it's right here. So these two quadrants. But remember that for sine, arc sine, we are limited to basically quadrant 1 and 4. So we're going to have to choose this one right here, okay? Square root of 3 over 2, which is, let me open up this one because this one kind of has it a little bit better. This is pi over 3. Okay, so that's what I did. I said I'm going to choose a value that lies in the range of arc sine. Oh, there's a little bit of glare there. And that came out to pi over 3. So my answer is sine of inverse square root of 3 over 2 is equal to pi thirds. And I do have one, oh, I'll show you that one right now. And yeah, that's it for that one. Okay, we have one tiny little example here, and it's super short because of because you'll see why. Basically, this one, I'm sorry about the glare, I'm having to cover things here. Basically, this one is not possible. So we have the inverse of sine. I'll show you that part in just a bit. The inverse of sine is -2. What angle gives me that? So this is not possible because the sine function is actually between these two guys, -1 and 1. So if we were to write it this way, -2 is not inside this domain. Therefore, we're not going to find any range value that goes with that. Okay, so that's it for that one. And I do have a note here. This is just kind of extra, but if you want to write it, you can. It says that even though sine y equals x, we think of y as an angle. So this right here is just a placeholder. It's like saying sine of what angle is equal to x. You don't think that this is the value y. It's just some angle. Which angle gives me this? Okay, so we're still looking for the y values for sine. All right, let's move on. Our examples. So I have all of the functions here now, the three main ones. We have arc sine, arc cosine, arc tangent. Go ahead and copy this while I explain, and I'm going to show you one little extra thing that I went ahead and did totally last minute because I thought, you know what, I think this will help them. We already kind of looked at sine, so quadrant 1 and 4. Our cosine is going to be it has a similar pattern, but this one's going to be between quadrant 1 and 2. So from 0 to pi. You're thinking like the top half of the unit circle. Okay, and arctangent is just like sine, so it's also going to be quadrant 1 and 4. Again, remember that sine y equals x, and the same for the rest of them is read sine of the angle y equals some number x. So before I show you the examples, I do want to show you this quick guide that I kind of made, again, totally last minute. I put it on the next page. You can put it underneath this if you'd like. And here's what it looks like. It's a quick guide for the range restrictions, just so you kind of know which part of the unit circle you're going to look at. For arcsine, we will be looking at quadrant 1 and 2. I'm sorry, 1 and 4. So basically the top half, I'm sorry, what am I saying? The right side of the circle is going to be arcsine. Okay. For arc cosine, we have quadrant 1 and 2. So we're looking at the top half of the unit circle. And for arctangent, it's just like arcsine. We're looking at quadrant 1 and 4, so the right side of the circle. So that's a quick way to kind of just know which angle to choose, okay, when you're debating between. So again, arcsine, arccosine, and arctangent. All right, and you can see that I even wrote the angles there, okay? Let's go ahead and look at some examples now. I did about 3 on this page. It says evaluate if possible. And I'm just going to go through it. I have to cover the square constantly. It says evaluate if possible arc cosine of square root of 2 over 2. So we rewrite it. Remember our equivalence statement, if and only if cosine of y is equal to square root of 2 over 2. Remember that cosine is going to be our x values. So where is our x value equal to square root of 2 over 2 in quadrant 1 and 2? So I'm going to look at my foldable over here, and I see that square root of 2 over 2 happens here in quadrant 1, and that's it. But remember, I only have to look at the top two for cosine. So a quadrant 1 at pi fourths, there's my answer. And this does make sense because pi fourth is within the range of this function. So this little notation here is just a really fast way of writing it, so you don't have to write the whole sentence. It reads pi fourth lies in the range of 0 and pi of y. So just a really quick way to write, you don't have to write all these words, just write it like this. That's it for that one. Second example, arc cosine of -1. So we're still dealing with cosine. I'm going to rewrite it as cosine of y is equal to -1. So where is our x value equal to -1? This only happens in one spot. It happens at the way end over here. X is equal to -1 right here, which is pi. And pi is definitely in that range, 0 and pi. So the answer is pi. Simple, simple. Last one, arctangent of 0. So for tangent, you have to think a little bit because you're thinking y divided by x. It's always y over x. So tangent of y equals 0. Where is y divided by x going to give me a 0? This happens in two spots. Okay, it happens on 0. So it happens right here because 0 divided by 1 is 0. And it happens over here. 0 divided by -1 is also going to be 0. But remember that tangent is basically these two quadrants, quadrant 1 and quadrant 4. So I don't care about this side at all. I'm going to choose this one, 1, 0, which is at 0, not 2 pi. Don't use 2 pi because 2 pi is not within your range. You're going to use the number 0 for that. So happens at 0, and 0 is within my range there. Okay, almost done with this video. I think we have maybe 2 more examples. Oh, actually, we have some more notes. Okay, maybe almost done. So we're almost done. So now we have some more stuff for you to copy. And this is just some inverse properties of these functions. So basically what happens when we do kind of like a double, I don't want to say a double calculation, but we do sine of arc sine. These two kind of balance each other out, and we're left with whatever that x or y is. Okay, so this kind of happens for all of them. So I'm not going to read through the whole thing here, but what you do have to be careful with is our restrictions. So if this value is not within the domain here, or this value is not within the y, the range, then we either have to try to find a coterminal angle that works, and if that doesn't work, then it's not possible. It's not going to work. So let's just jump right into it. I do have a note here that says the x and y values must be within the domain and range of its functions. That's just kind of what I just told you right now. So let's look at the first example. And you kind of have the answer, but that's okay. Find the exact value, if possible, of tangent of arctangent of -5. So the first thing you want to do is look at arctangent and say, well, what is the x of this? Okay, so my x, my domain, is going to be all real numbers. Okay, so since -5 is part of my all real numbers, this is possible. So basically, my answer is the same as whatever it is here, -5. Done. Okay, next one. Cosine of arc cosine of 0.54. So now we're going to look at cosine, okay, and we're going to see if 0.54 falls within my domain here. So 0.54 is definitely between -1 and 1. So I'm going to say that, yeah, this one applies as well. 0.54 is part of the domain, so the property applies. So it's just the same answer. And I think we're on the last one. Yeah, last but not least, here we have a coterminal angle, 5 pi thirds. 5 pi thirds is not within my value here, okay? So, and there's my definition there, okay? So what I'm going to do is try to find a coterminal angle with it. And I know that 5 pi thirds, if I subtract 2 pi, I get negative pi thirds. And negative pi thirds is within this interval here. So we can apply the property like this. This of this of this is equal to negative pi over 3. Okay, so this is the last example, and I did make a note that this is somewhat difficult, okay, only because you do have to kind of use a number of different, I guess different skills in this one. We're going to evaluate tangent of arc cosine of 2/3. So we kind of have two different functions. We can't use the property we just used right now for this one. Um, what I did to do this one, and I thought it was the easiest way to do it, is I kind of used a triangle to help me. So first of all, tangent of this is what we're trying to find. So this part right here can be rewritten as cosine of y equals 2/3. So where is cosine equal to 2/3 is what I'm trying to find. And if I can find that, basically, that's what's going to replace my tangent. So whatever this is equal to, okay? So cosine is not equal to 2/3 anywhere, not in our unit circle, which means we're going to have to construct a triangle here on the side and figure out what the other side is. Why? Because tangent uses opposite over adjacent, or y over x, whichever you prefer to use. So that's what I did here. Remember that this is read as an angle, so I have my angle y. And I know that cosine is equal to adjacent over hypotenuse. So if you want, you can write that here. This is equal to adjacent over hypotenuse. Okay, so I just labeled everything. So here's my adjacent side, here's the hypotenuse, here's the opposite. And with that in mind, I can go ahead and use Pythagorean theorem to find this missing piece right here. So a squared plus b squared equals c squared. Plug in what you know, 2 squared plus, this side squared equals 3 squared. Work it all out. I think you guys can kind of follow this part. And we end up with b is equal to square root of 5. So my opposite side is square root of 5. Okay. So plugging that back into tangents, I can go ahead and do it like this. I know that tangent is opposite over adjacent, so I just take my square root of 5, put it on top, my adjacent, put it underneath, and we're done. And this is basically our answer. If you wanted to write it a little bit more officially, we could do tangent of arc cosine of 2/3 is equal to square root of 5 over 2. And that is it for this video, guys. A little bit of an interesting topic. There's a few things I'm suspecting you might have some questions on. So if you do have any questions, let me know. And I can definitely help you out with that, okay? Thank you so much.